Okay, let's do a recall. Natural log of E is what? 1. What about natural log of 1? 0. At some point, it might be E. You never know, right? And then when we expand the natural log with it being multiplied, how do we expand it? Natural log of A plus natural log of B. It's not just E anymore, Xavier. E's done, expired, right? And then when we had a natural log with the inside component and a power, that came to the front, which meant this one was n times natural log of A. And to me, that kind of sounds like the rule of derivatives, except the minus one on the top. How do we expand the division? We subtract. Very good. Ooh, that's a B. And when I put 1 and 4 together, these two together is going to give us 6. Meaning, what would this simplify to?
N times natural log of A.
If natural log of E is 1, and I bring n to the front, it's going to cancel everything after the n. And guys, these are simply reviewed from pre-cal and even algebra 2 second semester. But in case you needed a review, here it is. All right? So on the bottom, let's go over the natural log from last semester. Go ahead and circle anything inside the natural log. And if I were to mimic this, it is 1 over u times a u prime. So in this case, our y prime is equal to 1 over that inside. And we multiply that by the derivative of that piece. What is the derivative of x squared plus 3? 2x. And that's it. What rule are we going to use on number 2 if I have x's on 2 different places? Product rule. Let's rewrite this. That is x times natural log of x. So as a recall, do we derive the first one or keep the first one? We derive, and then we keep the second one. And what sign separated between those two? Addition. Then we keep the first one. And when I derive the natural log of x, it's just 1 over x. And of course, times 1, because derivative of the bottom is 1. And the better answer to this when I simplify will be the natural log of x plus the 1, since the x's will cancel each other out. All right. Let's look at number, okay, let's go ahead and do the 3. On number 3, is something wrapping up the natural log overall? What rule was that from a long time ago? CH, chain rule. So the chain rule applied as the following. We bring the power over to the front. You keep the inside as it is, and 1 less power, which is 2. And then we derive the inside. What is the derivative of natural log of x? 1 over x, and that's it. All right, the next piece, number 4. Let's start by rewriting this. This is natural log of x plus 1 to the 1/2. This is not chain rule. The 1/2 is not being applied to the natural log and everything in itself. Okay? So let's go back to our rule number 4. On rule number 4, it says if you have natural log of some component to the power, that power comes to the front. Who is my power that's going to come to the front? This one. And we're not doing anything but rewriting right now. So 1/2 comes to the front. Then I have natural log of x plus 1. Now we can find the derivative. Whoa. So to find the derivative, the 1/2 I'm not even messing with. What is the derivative of this guy right here? 1 over x plus 1, and derivative of that is basically times 1 that we don't need, and I'm good with this. So be really careful as to knowing when is it chain and when is it not chain. This one, everything wrapped up, including natural log chain. That one is not. All right? It's a common mistake. Let's go on to example number 6. On example number 6, we have to rewrite this before taking the derivative. So here we go. When things are being multiplied, we add them to expand. So natural log of x plus, because of this power, I'm going to automatically bring that to the front. Natural log of x cubed plus 4. Uh-oh. Y'all have enough room? I'm stuck. And then on this one, it's on the bottom, so I need minus. The 1/2 is what's going to represent our radical, so I'm going to bring that to the front. And can I fit this? I don't know. Whoa, that's a 4. 4x squared minus 4. So now let's go ahead and derive. When I do, I get y is equal to, or y prime. The derivative of the first one is 1 over x. The second one, leave that 2 times 1 over that component times the derivative of that component. What is the derivative of the bottom? 3x squared. And then I'm going to leave the minus 1/2 alone. And did y'all realize I forgot the natural log piece right here? That's what happens when I don't have enough room. So we have times 1 over 4x squared minus 4. And what is the derivative of that? 8x. And that's it. All right, on the back, let's do number 8 and 9. Okay, on number 8. Allie, let's read number 8.
Locate the relative extrema of y equals...
Number 8.
Oh, number 8.
Mm-hmm.
Sorry.
That's okay.
Use implicit differentiation to find dy dx for x to the 5th minus 2 natural log of x minus, or plus y cubed equals 2.
So we're looking for dy over dx. So I need to go ahead and derive this with respect to x. And when I do, I get x to the power of 5 gives me 5x to the 4th. And then the next one, I already see a minus 2. And natural log of x is basically 1 over x. What is the derivative of y cubed? 3y squared. What do I need after that? dy over dx. And we know what the derivative of a constant is 0. So since my goal is to make dy over dx by itself, which I do see right there, let's do one go. We are going to subtract this one, and then we're going to add this one. So minus 5x to the 4th plus 2 over x, and divided by the coefficient of dy over dx. 3y squared, and that's it. All right. You ready for number 9? Last one?
Yep.
Okay. Hudson, let's read number 9.
Find the equation of the tangent line to be graphed in the equation. Y equals 3x squared minus natural log of x squared when x equals 1.
So when we're looking at tangent line, we're looking for a point. We are also looking for the slope. Which coordinate of the points has already been given to us? The x, To find the y piece, all I need to do is plug it back in. So I'm going to use my original equation. 3 times 1 squared minus natural log of 1 squared. What is, what's natural log of 1?
0.
0. It's not e anymore. So we're looking at 3 minus 0, which is 3. And that's going to pertain to our x1 and y1. To find the slope, we need to find the derivative. So the derivative of 3x squared is 6x. And then the derivative of the next one, we're gonna get, how many would that give us? 1 over x squared times that. Which in the end, when I plug in the 1 into this, we're gonna get the following. 6 times 1 minus 1 squared is 1 times 2 times 1. So how many is my slope? 6 minus 2 is 4. So we have y minus the y1 is 3. And then we have m, the 4, times x minus the 1. And that's it.